It's recording.
Okay. Hi guys, this is Zach and Nicholas. Well, Nicholas is on the camera, so you can't see him. And he says he's camera shy. So anyway, we are your tutors for MA1506. So we would like to present to you Tutorial 1, Question 4. Okay, so we'll look from the top. And what we see is our familiar XY Cartesian plane. So the candle will be over here. I'll use red to draw the plane. I'm not very good as an art student, but I try my best. So we'll let the moth be over here at r theta. And so the radial vector would be the vector from the origin to r theta. Okay, that's what radial vector means. And the moth is moving in this direction, say. So we can break up the velocity vector into two components. The first component is the radial component, which means in the direction of the radial vector, or the other direction. Okay? And the other component is the tangential component. So from your notes, you know that this is dr dt, and we know that this is r d theta dt. So they talk about angle psi. So this angle psi is this angle, the angle between the radial vector and the velocity vector. So when you turn the radial vector to the velocity vector, that's the angle between them. So it's very important that it's this angle and not the other angle, which would be this angle. Alright? Okay guys, I'm sure you got that. So we know this now. Tangent psi is equal to r d theta dr, and this psi is a constant. So this looks like a familiar ODE. I'm sure you all love ODEs by now. So we can solve. So I'll skip that. Magic. All of you love magic shows, right? So and the answer is r is equal to r naught, which is the initial length or distance from the moth to the candle, times e to the theta over tangent psi. Okay, so now when we understand this thing, this exponent part, we have to look carefully at the sign of this, because as t goes to infinity, e to the minus kt goes to 0, but e to the positive kt goes to infinity. Okay? So, well, here k is bigger than 0, alright? K bigger than 0. So, it's very important to know whether or not this exponent here is positive, because that determines whether it goes to 0 or to infinity. So it's two choices, infinity or 0. And we're not sure where it goes now. Okay, now let's look more carefully at tangent psi, and we'll change colors. All of these markers are free, so I can get many and use a lot of nice colors. Okay, thank you, math department. Okay, so this is 180 degrees, and this is 90 degrees. Alright? So for when psi is in 0 to 90 degrees, then tangent psi is positive. But when psi is in 90 to 180 degrees, then tangent psi is negative. Wow, that's great. Okay, now going back here, so this goes to infinity if we have this case. When psi is in 0 to 90, this goes to 0 when we're in this case, when psi is from 90 to 180. Okay, so what does this mean back in the diagram? Well, when psi is from 0 to 90, that means it's flying somewhere in this direction. So as you can see, the moth will keep on flying out, and escape. But what happens when it's from 90 to 180, as in this case? Well, that means the angle is something like this. So as you can see, the moth is going inwards, and you'll go something like that. And yeah, so oh dear. Yeah. So this is what question 4 is all about. Does it go to infinity or does it go to 0? And when does it go to infinity and when does it go to 0? Okay, hope you guys enjoyed the show. Yep, maybe we'll come back soon next time. Well, stay tuned next week or same time, same channel. Bye bye. Oh, you can turn it on.